So we shall start up with exercise 4.5. The remaining questions, we start from question number 13 now. So on continuation of exercise 4.5, we start with question number 13. A is a matrix, so it's given if A is equal to the matrix 3, 1, minus 1, 2. So A is a matrix of order 2. Then we need to show that A square minus 5A plus 7I is equal to 0. We need to show that this is equal to 0. Hence find A inverse. So for a given matrix A, we need to show this condition. We have to prove this condition. And using this condition only, we need to find A inverse. Hence find A inverse. First you need to show this, hence find A inverse. In this case, you cannot use the formula of A inverse, okay? After showing this, they are asking, hence find A inverse means after showing this condition, then you use it to find A inverse. It's very simple, especially for 2 cross 2 matrix. The same procedure is for 3 cross 3 also. Okay, same procedure, there is no much difference. So we have to show this first. In order to show this, let's find what is your A square, okay? A square means A times A, right? Here in matrix we don't have cross product, scalar product, dot product, so you can write dot as the product. It's okay. In vectors only we need to be careful with that. So A is your matrix 3, 1, minus 1, 2 times A. Your matrix A again 3, 1, minus 1, 2. So let us multiply. Both of them are of order 2, so our resultant also will be of order 2. How do we multiply? The first row will multiply the first column. 3 times is 9 plus 1 times minus 1 is minus 1, right? The first row with the second column, 3 1 times is 3 plus 1 2 times is 2. Second row with the first column, minus 1 times 3 is minus 3 plus 2 times minus 1 is minus 2. Second row with the second column, minus 1 times 1 is minus 1 plus 2 times 2 is 4. Here too you are learning it live, but when you go back home and when do you watch the video again? So how is it? How is the quality? Like, is it visible? Is it clearly visible? Okay. If it is not visible, or if it is the voice is not clear, then we can do some adjustments. No? 9 minus 1, 8. 3 plus 2 is 5. Minus 3 minus 2 is minus 5. And minus 1 plus 4 is 3. So we have obtained A square. Now we need to show this. We need to show that A square minus 5A plus 7I is 0. So let me take the left hand side. A square minus 5A plus 7I. Here I will be the identity matrix of order 2, right? So your A square is the matrix 8, 5, minus 5, 3, which we have obtained just now, minus 5 times your matrix A. 5 times your matrix A, your matrix A is 3, 1, minus 1, 2, plus 7 times your identity matrix 1, 0, 0, 0, 1. This is your identity matrix of order 2, correct? So this is 8, 5, minus 5, 3. You are going to now multiply this matrix with this scalar 5. Then all its corresponding elements should be multiplied by 5, right? So minus I can just keep as it is, and then 5 3 times is 15, 5 1 times is 5. 5 times minus 1 is minus 5, 5 2 times is 10. If you are multiplying with this minus 5 to all the elements here, then this will become positive, okay? It depends on how you are doing, alright? Plus multiplying the identity matrix with the scalar 7, 7 1 times is 7, 0, 0, 7 1 times is 7. Now if you are subtracting or adding 2 or more matrices, then all its corresponding elements should be added or subtracted. 8 minus 15, 8 minus 15, and then plus 7, right? Next, 5 minus 5 plus 0, minus 5 minus minus plus 5 plus 0, adding or subtracting all the corresponding elements depending upon the sign. 3 minus 10 plus 7. So this is 8 minus 15 minus 7 plus 7, 0. 5 minus 5, 0, minus 5 plus 5, 0. 3 minus 10 minus 7 plus 7 is 0, which is equal to the right hand side. 0 means your 0 matrix only. So we have proved. Now using this condition, we want to find out A inverse. Now we have A squared minus 5A plus 7I is equal to 0. We have this condition because we have proved this. Now what I'm going to do is, I'm going to multiply both sides by, in order to find A inverse, I have to introduce A inverse over here. A inverse besarable nimidi itu condition di A inverse to introduce koribo no. To A inverse to kinaka introduce koribo, you multiply both sides by A inverse. But multiplying also, you either need to pre-multiply or post-multiply. Pre-multiply means multiply to all the elements on the left by A inverse on both sides. Post-multiply means multiply to all the elements, to all the terms towards the right by this A inverse on both sides. Okay? So you can do either pre-multiplication or post-multiplication. If I do post-multiplication, then post-multiply both sides by A inverse. Then A squared times A inverse minus 5A times A inverse plus 7I times A inverse is equal to 0 times A inverse is 0. A inverse, we need to check actually whether A inverse exists or not. A inverse will exist only if the determinant of A is non-zero, right? Only if the matrix is non-singular. Okay. A squared, can we write A times A? And then multiplied by A inverse, right? Minus 5. A times A inverse means your identity, right? Any term, whether it's a matrix or not, anything multiplied with its inverse will be the identity. I times A inverse will be A inverse. Is it okay? Identity matrix into the inverse will be A inverse only is equal to 0. We have to adjust this. A times, can we write A inverse? Okay. Minus 5I plus 7 times A inverse is 0. A times A inverse is your identity matrix. Minus 5 5i plus 7a inverse is equal to 0. Your matrix A times your identity matrix will be A only. Minus 5i plus 7a inverse is equal to 0. I want to find out A inverse, so I have to transpose the remaining terms to the other side. So 7a inverse will be equal to AU. Keep it as minus A now on the other side. Minus 5i becomes plus 5i, right? Then your A inverse will be, okay, first your 7a inverse will be minus of your matrix A. Your matrix A is 3, 1, minus 1, 2. 3, 1, minus 1, 2. Plus 5 times your identity matrix 1, 0, 0, 1. I need some more space, so I'm going to rub this part. In that case, this implies your 7a inverse will be equal to, what is negative of your matrix A? Minus 3, minus 1, 1 and minus 2. Plus your identity matrix multiplied with scalar 5 will become 5, 0, 0, 5, correct? Then your 7a inverse will be now equal to adding two matrices, and all its corresponding elements should be added. Minus 3 plus 5, minus 1 plus 0, 1 plus 0, and minus 2 plus 5. So your 7a inverse will be equal to 2, minus 1, 1 and 3. So this implies your A inverse will be 1 by 7 times your matrix 2 minus 1, 1, 3. So this is your A inverse. Is it okay? So similarly, the rest of the questions is similar to that of this, except that in some questions you have 3 cross 3 matrix, okay? Let me do the next one also. Question number 14. Is it clear to you? Okay. In question number 14, we have for the matrix A, which is given to be 3, 2, which is given to be 3, 2, 1, 1. Find the numbers A and B. Find the numbers A and B. We have to find A and B such that A square plus small a times the matrix A plus small b times your matrix I is equal to 0. Oh, this is the given condition now. In the previous case, you needed to prove the given condition. But this time, this condition is given, and using this information, you need to find out the constants, the scalars A and B. Here, small a and small b, they are not matrices, but they are any scalars. Okay? So using this information or the condition, you need to find out the scalars, small a and small b. Since we know a, so we find what is a square. A square means a times a. Your a is 3, 2, 1, 1 times your again a is 3, 2, 1, 1. So we multiply. First row will multiply with first column. 3 times is 9 plus 2 1 times is 2. That's the first element. Second element of the first row will be, you multiply the first row with the second column. 3 2 times is 6 plus 2 times 1 is 2. Second row will multiply with the first column. 1 3 times is 3 plus 1 1 times is 1. Second row will multiply with the second column. 1 2 times is 2 plus 1 1 times is 1. So a square is 11 8 4 3. Is it okay? Now we have a square plus a times small a plus b times I is equal to 0. Right? We have this condition. We know what is a square. If we multiply both sides by a inverse, we don't require that. Then a square means 11, 8, 4 and 3 plus scalar a times your matrix A, 3 2 1 1 plus scalar b times the identity matrix. Here the identity matrix is of order 2 is equal to 0, utilizing the given condition. So 11 8 4 3 plus multiplying this matrix with scalar a means all the elements must be multiplied with that scalar a. 3a 2a a. Identity matrix multiplying by the scalar b will become b 0 0 b is equal to. Is it okay? Then what do we have is you are adding 3 matrices, so all its corresponding elements should be added. So 11 plus 3a plus b, that's your first element. 8 plus 2a plus 0. 4 plus a plus 0. And then we have 3 plus a plus b is equal to 0 means your 0 matrix, right? 0 means your 0 matrix. Then in that case, here this is equal to your 0 matrix. So if two matrices are equal, then all its corresponding elements should be equal. So I'm going to take this, suppose 8 plus 2a, 8 plus 2a will be equal to 0. So 2a will be equal to minus 8. So a is equal to minus 4. And then in order to find out b, I can take this element, okay, or this element. 3 plus a plus b is equal to 0, right? And this element corresponds to this, right? So 3 plus a plus b is 0. 3 plus we have obtained a, which is minus 4, plus b is 0. 3 plus minus 4 plus b is 0. Minus 1 plus b is 0. This gives you b as 1. So the scalars a and b have been determined using the given condition.